because most of the sound wave manipulation we have is amplitude, volume. Okay, all right, turn stereo up. And period. Okay. Change the period function, it changes the pitch or frequency of your sound. Okay. Like I said yesterday, we don't shift anything in music, so this is the pure mathematics part of your sound waves. We will get into tomorrow. I will show you exactly how to plug your frequencies into your function. Super easy. Okay, it's just a formula. But for now, that's where we're at. And you're just about to the point where you start writing your functions and graphing them and start really writing a report. Okay. Let's graph sine x. Yeah, I used to have this and I just didn't grab it until this time of the year. This year. Okay, we'll go from 1 to -1, right? And 0 to what?
2 pi.
2 pi is the period of sine x.
Oh, you said it like 12 times.
Sine x. Amplitude is 1. And the period is
2 pi.
the amount of time it takes to repeat a cycle. Okay. How do you manipulate those two items? Okay. So amplitude, period. We'll talk about amplitude first because it's really easy. It's a parent function manipulation just like you learned in chapter 3. So let's say I do this. What did a number multiplied in front do? Stretched it vertically, made it go up faster. Okay, so this is an amplitude change. Makes it stretches vertically. Okay, so now the amplitude is 2.
So it's just steep.
Now we go for there. Amplitude change. I don't know if you remember, I showed you on Audacity the first day when the guitar was louder, and then it quieted as the string tempered. The sound wave actually got shorter. So that's an amplitude change or volume change, okay? Super easy to manage. In your project, you're going to choose that number. Okay, most people choose 1 or 2. It's super easy, but it's your choice as to the amplitude you put in your project, okay? I'm not going to regulate sound. Volume anyways. Okay, how about one more? Do you remember what a negative out front does to a function? So we reflect over the x-axis.
Is that negative?
So you're going to start going down?
Yeah, reflect.
That was easy.
Over the x-axis. Yeah, start down. Then if you're real cutesy, you can make art out of math.
Oh my god.
Very good job.
You got bags of your legs.
There's something wrong with that guy's Let's go.
Alright, so there you go.
He's having a little bit of fun. He's pink eye and bows that he is.
Okay, gotcha.
What?
Are we naming him?
Give an amplitude change.
Not amplitude.
This is
Looks like I
I knew these
Yeah.
We're naming him Amplitude.
You look so good.
That's our amplitude.
Amplitude.
My cousin had you in the game. Yeah, we should.
Y'all like it. I like how you laugh. You're like,
All right. Next page. Let's explore changes in period, cosine.
Do that.
I go see the
Yeah, I probably do as well. Oh, cosine, oh, you start at 1 and then go
Okay, start at 1 and go. What does that mean?
No, I didn't just say shish.
That's all I heard.
Oh, I
Where's
forgot.
it in?
there.
Up on, it's at 1.
Right there.
In the middle where we go.
I made a sound effect, but I don't know which one it is.
At pi,
Over 2.
It cuts through.
the value of cosine is
Pi.
No, pi is 0.
cosine of pi is
0.
or negative 1.
Negative 1.
Negative
I
1.
was looking at the wrong graph.
So it looks like this.
And then both zeros would be
Now we're gonna have a creepy clown.
pi over 2 and then 3 times
To manipulate the period of a function. We are gonna, this is no longer gonna repeat at 2 pi. We can make it repeat at pi, we can make it repeat at 1, we can make it repeat at 10 pi. Okay, it all depends on a value that happens to be paired with the x. That controls our period change. Okay, any number in front of the x will control our period change. Now it's just a little formula, and the period is 2 pi over whatever number that is in front of the x. We call it k. So if you get a number here, 2 pi over that number gives you the new period to graph that function under.
But what if the original period wasn't, oh, never mind, that was about to be really dumb.
The parent function's 2 pi, this would be a child.
Self-control?
Yeah.
Some child go crazy, some child. Okay, so. All right, let's try.
I don't, I just keep going.
So you should work on that. It's humorous for me.
So it's 2.
Okay, cosine 2x. What's our value of k? 2. So what is our new period? 2 pi over 2, which is
2 pi over 2. Which is pi.
now you have to smash that into pi units. Same graph,
What day?
put it in pi.
Make a lot of sound effects.
Yeah, they're great.
They're great. I love them. Whoa.
That's a period change to pi units. So it repeats in that interval.
Whoa, it's so weird.
Oh, that makes sense.
And so with the frequencies, we just plug the
This would be-
frequency into the k place.
So is it just like one single?
I'll give you the formula in a minute.
Okay.
What about sine over there?
This is
Wonder anything is so
a higher pitch sound.
Right,
red
it's
one?
moving faster.
Speed of sound doesn't change,
Well,
but the number of cycles per second passing will be double of the original parent function. So this would be a higher pitch sound because the
Oh, so whenever the
wavelength
number in
is
front of
shifted.
it, the pitch is gonna be higher?
Yeah, and if it's a longer period, you're gonna have a lower sound. You like bass, right? Okay. Long wavelengths.
She does make long noises.
Versus
See, I'm telling you, it's like the fourth sound effect you made.
okay, there's number 5 for you. Perfect. Okay, what do you do?
This time you should have.
You get high.
That, what's the period of that function?
Is that pi then?
Yep, cosine pi x.
2. Yeah.
Yeah, 2 pi over pi, right?
It'd just be 2.
2. Where's 2?
Two is up.
Or no, it'd be on 1 or something.
Yeah. Would it be?
No,
Really?
this is 3.14, correct? Pi?
Oh, yeah. Oh.
Where's 2?
That's weird to think so. Oh, good question. That is so weird.
There's 1.57. Yeah, 2's gonna be somewhere there. Right?
That's so.
Now you would have a function that
Whoa.
is not defined on a unit circle friendly interval. So you have to work with that because lo and behold, music is not defined on unit circle friendly intervals. Time is just what it is. Okay? That is a period change and thus a pitch or frequency change for your music purposes. Okay? Question. You want me to show you one where we combine the two? Okay, all right, so here's your music, writing your music function, okay, for your sound, for your sound waves. They're always sine functions. This is the formula you're going to use. This is frequency.
Oh, move on to a whole different, okay.
Okay. So let's just study an middle A4, middle A. .440 hertz. Remember, that's 440 cycles per second. What is your equation? We'll figure out the period. And the period gives you the time interval of 1 cycle, right? And it's very fast. These are 440 cycles coming by your ear every second. 0.000, we get into the 10,000s. So what's our sine function? 2 pi, 440, x. Most of the time, okay, we can do this. We will write a t. Why do we put t? Yeah, time. Context, right? So we would want to rewrite this 880 pi t. Okay? There's your equation. You have to write 6 of those. For proficient, 6 notes, 6 equation.
Oh, so we got.
So whatever your notes are,
Okay, so that makes sense.
you might have an overlap. Okay. You might pick an A chord and you might pick a C chord, and they might both have an A in them. Overlap is okay. So you'd only have to have 5 at that point, right? I'm not, okay, so sometimes there's overlap, it makes it easier. It shows it, you still know the information, right? That's what I'm concerned about showing, okay. What is the period of this function? 2 pi over 880 pi. That's your k value, right? That's your k value. Now just simplify mathematically. 1 over 440. What does that look like? So 1 over the frequency. So you can make it simple, okay? 1 over frequency is the period of a sound wave. Anybody have a calculator handy?
Yeah.
What's 1 divided by 440?
Everybody put them down.
0.00227.
Seconds. Every 0.00227 seconds, one cycle of that sound wave passes your ear.
That's pretty cool.
The eardrum is an amazing thing, right? But it could just vibrate 440 times in 1 second, process that, and your brain interprets it instantaneously.
So I'm like, well, I thank you guys. I thank you, viewers.
Yeah, take care of them. Trust me,
So
it's not fun not being able to hear a lot of stuff.
I'm this year's
All right, so now at this point in your project, you've picked your song, you've picked your chords, you've decomposed those chords into notes, you found your frequencies, and now you can write your function. Feel free to make the amplitude whatever you like. Your choice. Okay? I will teach you how to graph these. Well, we already taught you how to graph them by hand. Okay? I will teach you how to graph them on a computer with Wolfram Alpha so that you can insert them into your project papers. Okay? Questions? Okay. 6.4.
Okay, right now.
No, that's what you don't get this pen.
You are the mastermind.
This is a bit, or whatever. That's like taking Oh, for a second I thought it said 9, oh, there's 150.
What's
Yeah, you know me, man. It's the same old G.
What is
I thought you were signing 90 through 150. I said, yeah, you know me. It's the same old G. Signing 150 math problems to practice.
Yeah. What is it?
These are music problems.
Oh, God.
Oh, well,
Your
there you
book
go.
actually includes music problems in it. Lo and behold, they are just exactly like I showed you here.
What is the little thing?
Yeah, I'm gonna do this.
That's an asterisk,
Oh, I do that too.
music problems.
Oh.
I never even knew they were called that. I just called them stars.
Yeah, asterisk. No idea where that word came from, but
I didn't even know they were called that.
that's what it is.
That's how you know the
That's what I thought about.
Okay, that turns out, that's,
That's what